Hello friends, welcome to this video on random process. This is going to be the fifth video in this series. We are going to see about a problem dealing with WSS, and in particularly we are going to see where the random variable is going to follow a particular theoretical distribution. If that is going to be the case, then how to handle the WSS process. That is going to be the concept covered in this video. Come on, we will quickly move into the video. The problem is that we will have to show that the random process x of t, which is a cos omega t plus theta, is WSS if a and omega are constants and theta is uniformly distributed random variable in the interval 0, 2 pi. First and foremost, the problem is to show that it is going to be WSS. So we need to quickly recollect what is going to be the concepts or the points to be proved if a random process has to be shown as WSS. So we can recollect that the points to be proved for WSS is condition number 1, mean, which is expected value of x of t, is a constant. Second condition, autocorrelation function r of t1, t2 must be a function of tau. Tau is nothing but time 1 difference time 2. So expected value of x of t1 product x of t2 must be a function of t1 difference t2. So this is going to be the 2 points which we will have to show if we need to prove that the quantity is going to be a WSS process. So for a WSS, this is my condition number 1 and this is my condition number 2. Now the second thing to observe. Over here, A is a constant, omega is a constant. What we need is over here. This theta which is inside the cos, that is an angle, has been defined as it is uniformly distributed random variable in the interval 0, 2 pi. So it cannot be handled in the same way like expected value of A or expected value of lambda, what we did in the last problems. So we need to see how we can handle the random variable which is following a particular distribution over here. So we will make use of a formula related to this theoretical distribution. So whenever we have the random variable to follow any particular theoretical distribution, then we can say the expected value of g of x is integral from minus infinity to infinity g of x into fx of x dx. G of x is the input which we have given for our expectation. And what about this fx of x? This fx of x which we have over here is nothing but the marginal density function of the random variable x. So whenever we give the input over here, the corresponding function's marginal density function has to be multiplied to get the value for the expectation. Now, what is said in our problem? Our problem is such that theta form follows uniform distribution. And what do we know about the marginal density function of a uniform distribution? So when theta is going to be, x is going to be uniformly distributed in the interval a less than x less than b, then the marginal function is given by 1 divided by b minus a for a less than x less than b. In our case, what we have is going to be theta. So what will be my f of theta? My f of theta will be equal to 1 divided by b minus a. Where is my theta distributed uniformly? In the interval 0 less than theta less than 2 pi. So the value will be equal to 2 pi minus 0, b minus a. So my f of theta will be equal to 1 by 2 pi. So I will have to be very cautious enough to include this marginal function before integration and then apply it with the corresponding expected value. So come on, let us move on to solve the problem. So we are going to solve or show that the problem is WSS. We will begin with showing that the mean E of x of t is going to be a constant. So the primary target, condition number 1, to show mean. What is going to be mean? Expected value of x of t. So this becomes expected value of what has been given as a x of t? A cos omega t plus theta. A cos omega t plus theta. What is the rule of A here? A is a constant. We need to keep in mind expected value of AX is A times expected value of X. Constant will be pushed out and only the random variable will be applicable to the expectancy operator. So now this gives me A times expected value of cos omega t plus theta. And we know that the theta over here follows what distribution? Uniform distribution. So this is something like my expected value of g of x. And so what will be expected value of g of x? Integral g of x into fx of x dx between minus infinity to infinity. So what will be the expected value of cos of omega t plus theta? So this will be now integral cos of omega t plus theta into this fx of x, where theta is going to follow uniform distribution is given by fx of theta or f theta of theta. F of theta will be equal to 1 divided by b minus a. So this becomes 2 pi. So I now have to multiply this f of x, which is 1 by 2 pi over here. And the integration is with respect to which variable? Theta, not x, as defined in this function. And where is the limit of integration? Limit of integration is between 0 to 2 pi. So what we have over here? The expected value of cos of omega t plus theta is now equivalently changed as 0 to 2 pi cos omega t plus theta into 1 by 2 pi d theta. This is my g of x, which is the given input, or g of theta, which is the given input, and this is going to be my f of theta, which is going to be the marginal density function of my uniform distribution. Okay, so now we are ready to apply it to the formula. So now this will become A times, what is this expected value is replaced with? This expected value is replaced with 0 to 2 pi cos of omega t plus theta into 1 by 2 pi. This 1 by 2 pi is a constant. Let me take it outside, and the integration has to be done with respect to theta. We need to recollect what is integral of cos theta. We know that integral cos theta d theta is equal to sin theta. So what we have from the previous page, this is going to be equal to cos on integration sine of omega t plus theta. So integral is going to be sine. So let us resubstitute it over here. So we have the value of mean to be equal to a divided by 2 pi sine of omega t plus theta, and the limit has to be applied for theta between which variable? The values over here are 0 to 2 pi. So apply 0 to 2 pi for my theta. So now this becomes a divided by 2 pi. Applying the upper limit, it becomes sine of omega t plus 2 pi minus lower limit becomes sine of omega t plus 0, or it is sine just omega t. What is going to be 2 pi? Whenever we have our all silver tea cups, 2 pi. This one full circle will be called as 2 pi. When I cover all the four quadrants one, it will be covering 2 pi. What will be 2 pi plus theta? It will be in my first quadrant. So what will be sine of omega t plus 2 pi? It will be sine omega t. Now considering the second term, 0. What is 0? 0 is the starting point. So it has not moved at all, and hence what we have over here is simple sine omega t. So I have sine omega t minus sine omega t times of a into 2 pi. So this leads me to the value of 0. So what we have finally achieved is mean is 0, and this is nothing but the constant. So what we have proved by the WSS process, I have now shown that the first point, which is mean, which is expected value of x of t, is going to be a constant. Now, having proved the first point, we move on to the second point. What is the second point? Proving that autocorrelation function is a function of tau. So now we will define what is going to be autocorrelation function. So it is Rxx of t1 comma t2, which is expected value of x of t1 product x of t2. What is going to be x of t for me? It is a cos omega t plus theta. So what will be x of t1? It will be a cos omega t1 plus theta. What will be x of t2? It will be a cos omega t2 plus theta. Now resubstitute the value of x of t1 and x of t2 in the corresponding position. Now this gives me a cos omega t1 plus theta into a cos omega t2 plus theta. The role of a over here is constant. So acknowledging the formula, expected value of ax is a times expected value of x. What happens to this a into a square, which is the constant, comes outside, leaving us with cos of omega t1 plus theta into cos of omega t2 plus theta. Now this is the random variable theta, which is going to be uniformly distributed. So whenever theta is going to be uniformly distributed, what will happen to my expectation? I will have to apply the formula. Expected value of g of x is integral g of x into fx of x dx. What is this fx of x? It is the marginal density function. So now I have it as a square integral. What is the input which we have in place of g of x? This is my entire g of x. So I write it as cos omega t1 plus theta cos omega t2 plus theta. So g of theta has been got. What this has to be multiplied with? F of x or f of theta. What is f of theta when it is uniform distribution? We will have to recollect that f of theta is going to be equal to 1 divided by 2 pi when it is uniformly distributed in 0, 2 pi. So we multiply by 1 by 2 pi and then dx is nothing but d theta for us. And where does our theta vary? Between 0 to 2 pi. Now this is going to be of the form cos A, cos B. This cannot be integrated as such. So we will take the help of trigonometric identity to prove this. What we know about cos A, cos B? It is half cos A plus B plus cos A minus B. So applying it over here, what we have? This is going to be my cos A and the second one is going to be my cos B. So this is going to be my cos A and this is going to be my cos B. So this 1 by 2 pi can be taken outside. So I have it as a squared divided by 2 pi integral from 0 to 2 pi. What is going to be this 1 by 2? This is again a constant. So take it outside. Cos of A plus B. What is in place of A plus B? This is my A. This is my B. A plus B. So what we will be having? Omega t1 plus theta plus omega t2 plus theta. And second term is plus cos A minus B. Omega t1 plus theta minus omega t2 minus theta. The entire quantity has to be integrated with respect to d theta. So I have this as a square divided by 2 2's are 4 pi. Let me split it into two integrals so that it will be easy for me to evaluate. Cos of omega times t1 plus t2 plus what we have over here is theta and theta. So that makes it as 2 theta d theta. This is my first term plus Second term, a square divided by 4 pi integral from 0 to 2 pi cos of, what happens over here? This will give me plus theta, cancelling off with this minus theta. So I will have omega of T1 minus T2 into d theta. Now we will have to integrate these two quantities to get our answer. Let me term this as to be my integral 1, I1. This is going to be my I1 and this let it be equal to I2. Now let us first evaluate what is going to be my I1. What is my I1? A square divided by 4 pi integral 0 to 2 pi cos of omega T1 plus T2 plus 2 theta d theta. So omega T1 plus T2 plus 2 theta d theta. So what is going to be integral of cos theta d theta? It is going to be sin theta. What will be integral of cos of a theta d theta? So whenever we have it as integral of cos of a theta d theta, this will be sine of a theta divided by a. So the constant has to be divided. So now this gives me a square divided by 4 pi sine of omega T1 plus T2 plus 2 theta divided by, what is the angle by which I'll have to divide by? The constant. It has to be divided by 2 because the constant value is going to be equal to 2 over here. Apply the limit between 0 to 2 pi. So now what will happen? This will become a square by, this will 2 will come outside, 8 pi. So this will become sine of omega T1 plus T2. Theta takes the upper limit. So this will become 2 2's are 4 pi, the upper limit minus lower limit sine of omega T1 plus T2 plus 0. So now we will look into the 4-quadrant formula again. All silver tea cups. What is going to be 4 pi? When I complete one full circle, I will be covering 2 pi. What will happen when it is 4 pi? I will be covering this circle one more time. So I will be ending up in the baseline. So where will be 4 pi plus theta? It will be in the first quadrant. So this will give me sine of omega T1 plus T2. What will be the second term? Minus plus angle is going to be 0. So the 0 will be here in the baseline itself. Hence I will be left out with sine of omega T1 plus T2. Now we notice that the first term and the second term are one and the same. So on subtraction, what does our I1 lead to? My integral I1 is nothing but equal to 0. Now we have the second part over here to concentrate on. So what is going to be my I2? We will move on with I2. What is I2? I2 is a square divided by 4 pi integral from 0 to 2 pi cos of omega T1 minus T2 into d theta. Now we notice that the integration has to be carried out with respect to which variable? Theta. But when we look into the function which is inside this integration, do we find any theta here? No. Inside the integration, I don't have any theta at all. So this part which is going to be independent of theta will be treated as a constant. So it becomes a square divided by 4 pi. This constant which is cos of omega T1 minus T2 comes outside, leaving you with 0 to 2 pi d theta alone. What is integral d theta? It is theta between the limit 0 to 2 pi. So when I apply upper limit minus lower limit, it becomes 2 pi minus 0. And what is going to be the quantity which is left out for us? Cos omega T1 minus T2 into a square divided by 4 pi. Now what happens? This 4 pi can be cancelled off with this constant 2 pi over here, leaving you with A square divided by 2 will go over here 2 times. So 2 will be remaining. What I will be having is cos omega into, now we'll have to notice what is this? T1 minus T2. What is the way to represent T1 minus T2? We always represent it by tau. So what I have finally over here? I have a square divided by 2 cos omega tau. So this is a function of which variable? It is a function of tau. Hence, I have a function of tau. Hence, I have proved my point number 2 also. So, the 2 points to be proved for a WSS, namely mean is a constant and autocorrelation is a function of tau, has been proved, and hence what we finally conclude, the given random process is going to be a WSS. That's it, children. Have a nice day.